and welcome to MakerFun Moments powered by Brilliant Labs.
Hi, I'm Ian, and I'm so glad you could join us. Yes! MakerFun has been taken over by students. We have lots to learn, create, and explore with you. Let's get started. Did you know that the first geopark in North America was Stonehammer? And it was named a UNESCO site in 2010. Stonehammer is a 2,500 square kilometer park in southern New Brunswick. It was created due to earthquakes, volcanoes, and climate change. If you're ever in St. John, New Brunswick, be sure to visit the Stonehammer site near the Reversing Falls Rapids. This gorge was created during the Ice Age, and you can see where the two continents were joined. Oh, awesome! We have a MakerFun caller. Hi, I'm Ian. How can I help?
Hi Ian, I'm Kate. I've collected all these rocks for a school project. Now I have to sort them into categories and share my data. How do I do that?
No problem, Kate. I can help you with that. But first, let's see if you can do this data project with us. Let's go get some samples. Collect 3 to 5 rocks, toys, or anything that is similar. Study them. This is your chance to be a scientist and use quantitative and qualitative data. Qualitative data can be answered by asking yourself observation questions like, what color is my object? Is it rough or is it smooth? Quantitative data questions can be answered by using tools like, how long is my object? Or how much does it weigh? Remember, when you're collecting your qualitative and quantitative data, be sure to take notes. We'll answer the project question at the end of the show. In our last MakerFun episode, we shared that there are 17 sustainable development goals to help make our world a safer and better place. Today, we're going to explore goal number 15, life on land. This means that countries and corporations need to work together to find sustainable practices for our natural ecosystems. Let's explore the science of geology, also known as geoscience. Now you're probably wondering, what's geoscience? This is the study of Earth's history and the life that's lived here for billions of years. Did you know that the oldest rock found by geoscientists was over 4 billion years old? And it was found in the Hudson Bay area of Canada. Rocks help geoscientists learn more about Earth's history and also how to help us in the future. In this episode of MakerFun, we'll speak with a geologist and learn about sustainable mining practices. We'll learn about fossils and even make one. We'll explore a geopark and help us learn about the rocks that make up our Nova Scotia coastline, and we'll learn about the rocks in our community. Now, let's have a little MakerFun. Have you ever found a rock that looks like a plant or an animal? Maybe it was a fossil. A fossil is an imprint of an organism that lived millions of years ago. It can be a part of the organism, or just a trace of it. Let's go learn about how we can make a fossil of our own.
A fossil is any evidence of prehistoric life, like a plant or an animal, that is at least 10,000 years old. The most common fossils are bones and teeth, but they can also be footprints and skin impressions. To make your own fossils at home, you will need 1 cup of used coffee grounds, half a cup of cold coffee, 1 cup of all-purpose flour, half a cup of salt, a mixing bowl, and any small objects like a cookie cutter or a butter knife. What you want to do is you're going to brew a small amount of coffee, or you can make a little extra in the morning and save the grounds. After you do that, you are going to want to let the coffee cool because we want cold coffee. My mom made some coffee this morning, so that's what I'm going to use now. Next, you'll want to mix the coffee grinds, the flour, and the salt together in a bowl. Next, you'll want to mix the coffee grinds, salt, and flour together and slowly add the coffee bit by bit and mix the dry ingredients until the mixture forms a dough. The amount of coffee you need depends on how wet the grounds are. Now you're done mixing, and the mixture should look something like this. So now what you're going to want to do is scoop the dough onto a pan, or just keep it in your bowl. And you're going to knead it for 3 to 4 minutes before it becomes less sticky and it holds its shape. Now you're done kneading, you're going to want to spread it out and cut it into circles, either using a butter knife or an empty can or a cookie cutter. After you're done cutting the circles, you are going to want to take your objects chosen and you're going to want to place them into the circles as a mold. Once you're done making your imprints, you can use a toothpick or something sharp to poke holes into your mixture, so like you can tie a string on it and hang it on your wall. Earlier, we preheated our oven to 200 degrees. Now it's done preheating, and we're going to put the mixture into the oven for 45 minutes. But if you have a thicker mixture, you might want to put it in for longer. Okay, so this one was a leaf, this one was the ring, and this one was a fork. Most fossils you find in the wild are going to be pretty hard to see, just like these ones. So what we're going to do is we're going to paint them. You can paint them with paint, bingo dabbers, or whatever you have in your house. I'm going to use bingo dabber. The colors I have chosen are pink and blue. The fork isn't as interesting as the leaf, but it is pretty cool because you can see like the little bumps and stuff. Now I'm gonna do the ring, and for the ring I'm actually gonna use red paint just to see how it turns out. Look at that, you can see like the little bumps from the ring. I like the ring the best. This was a lot of fun. I really liked painting them to make them more visible because I really felt like a paleontologist or an archaeologist. Have fun making your own fossils. Bye!
That was so much fun! Now, let's go talk with the real scientists about rocks and mineral mining in Nova Scotia.
My name is Denise Brusha, and I'm a geologist with the Nova Scotia Department of Mines and Energy. I'm a official geologist, so I study and map and sample everything, all materials that are above the bedrock. I study the sediments and everything that happens above the bedrock.
What does studying the bedrock or the stuff above the bedrock have to do with mining?
Studying the superficial geology, or the sediments that are above the bedrock, is really important for mining, for the exploration side. So when we do that, part of that is regional mapping. So we want a large area where we go out and we map. And then we also take a lot of samples so that we can see what that composition is over a large area. And then once we study the samples that we take, we look at the geochemistry. And then we can start to see different patterns in different areas. And we can use that to study groundwater or our water, if there's any contaminations. There's environmental applications, but there's also exploration applications. So if we find a sample that has a lot of, say, gold in it, well, then you know that in future studies, you're going to go back to that area, and that's where you're going to focus on your work. And you're going to keep focusing until you get narrow into an area that looks like it's going to be the most likely to have some sort of bedrock or some geology that's important for a new deposit or for mining.
So what is mining, and how does the stuff on top of the rocks help you understand the stuff underneath the rocks?
That's a great question. So in Nova Scotia and in most of Canada, it was covered by glaciers. So we've had repeated glaciations where the ice has covered the land and then it's retreated, and then that happens again. And every time that the glaciers do that, as the ice moves, it picks up pieces of that bedrock. It picks up everything and it just plows the land. And what that does is it's also picking up that bedrock. So it has content in it that we can use to find out where it came from. If we know the way that the glaciers moved, if we know how far they moved, well then it's a detective game and we can start piecing it together, and then we can go back and we'll have a better idea of where to look for our subject of interest, whatever it is that we're looking for. But the glaciers are a key part of that story. And that was my biggest research interest.
Awesome. What kind of resources are you looking for, or are mining people looking for?
In like I said, a lot of in Nova Scotia, it's always been a lot of gold and other base metals. And now what's becoming more important is critical minerals or strategic minerals. And these are the type of minerals that are used in cell phones, in technology, in your TVs. And those minerals they're a lot harder to find. And Canada is looking to see what do we have for critical minerals that we can explore for and that we can study here in Canada. And so those critical minerals, like they include things like lithium batteries. So that's a really big one. And that includes things like lithium and tin and cobalt and all of those minerals. Well, we have some of them in Nova Scotia and New Brunswick and Atlantic Canada that we're going to try to be focusing on more now and for the future.
Those are the ones that you're looking for clues. You're looking for clues in like the soil and the ground for what's further down?
Exactly. Because in many places you can't see the bedrock. So you don't know what you can't see. So you have to look for other clues. And those clues, well, they come from those soils and those glacial deposits.
Can you tell me how does a glacier move across land? Ice doesn't walk, or it's not alive. How does a glacier move across the land? And how does it pick up rocks?
When glaciers are formed, there's different types. There's large, continental scale glaciers, and they covered all of Canada. They covered most of the world at some point. And those glaciers, when we're talking continental scale, this ice, it's taking such a long time to form, and it starts with snow. And that's going to happen during colder periods in our history. And with that snow, as that accumulates, and it turns into ice, and it becomes thicker and thicker. And that ice, it's always moving. It's always flowing. We can't see it. It looks really slow, but it is, and it's really powerful. And these large glaciers that cover, most of, North America, 100,000 years ago, well, those glaciers, they're not going to stop when they get to, a river. They're not going to stop when they get to a mountain. These are thick bodies of ice that are a kilometer thick. So they're just going to plow everything, pick up lots of material, and then they're going to deposit them into landforms that we see. And we have that a lot here, in Atlantic Canada. We see lots of these beautiful egg-shaped mounds, even in Halifax, and these are drumlins, and they're all left by the glaciers.
What's your favorite part of the field work that is the most fun? What's the most fun part of your job?
Definitely the helicopter work. It's such a different perspective, and especially in summer, it's beautiful to be up in the air, and as soon as you get up there, it's such a different perspective where you can really see what the land looks like. You get such a different picture of what the land looks like when you're above it and looking down that you just can't get when you're standing on. And it's just some beautiful landscapes to see as well. And it's also best for animal viewing too. So you'd be surprised once you get up in the air just how many animals that we're surrounded by.
Oh, very cool. It's been amazing talking to you. Thank you so much for joining me. And I look forward to meeting with you again.
Let's keep exploring. Our friend Lennon is at a geopark in Nova Scotia. What rocks have you found, Lennon?
And today we're going to be looking at the rocks in the Bay of Fundy. Look at the edge of this rock. It's so shiny. It might have something called quartz in it. These types of rocks are a type of rock called sedimentary rock. But I wonder what these are. Some of the sedimentary rocks around here are gypsum, sandstone, and fossils. Let's see if we can find a fossil. Hey, this is sandstone. It's made of sheets of sand and rocks in the middle. Different minerals will cause different colors and rock formations. Sometimes copper will cause a greenish color.
Billions of years ago, there was one supercontinent called Pangaea. But 175 million years ago, it began to break apart and create the 7 continents that we know today. That rocked! Now, check this out.
Hi, my name is Lenny, and today we're going to be looking at all the geology in the world. What kind of rock is this actual rock? This looks like it has lots of different rocks and minerals in it. It must be metamorphic. This rock is actually a big clump of smushed together rocks under high temperature. This is a metamorphic rock, and this is a piece of wood. Canada is a great place to study geology. What kind of rocks have you noticed around your community? For example, this is a beautiful piece of quartz. The rust color could mean a presence of gold. In fact, Nova Scotia is a great place for mining, for such as gypsum, sandstone, and gold. I wonder what minerals you have in your backyard. Maybe you found gold. Well, I'm pretty sure that we know that rocks rock! Why don't you share with us the rocks and minerals where you live? Thanks for joining us today with Rocks and Minerals. Stay brilliant!
Do you remember the project question at the beginning of the show? Well, why don't we work it out together? Here I have 3 rocks. 1 is white, and 2 are a gray color. Over here in this side, I'll put the white rock, and these 2, because they're the gray rocks. So this is an example of qualitative data. Now we'll take these rocks and we'll measure them. Notice how this rock is longer than the rest? So we'll put that in its own pile. Maybe this one is about in the middle, and this one smaller. So here we have 3 separate groups. This is an example of quantitative data. What was your favorite part of today's show? Did you make any projects that you'd like to share with us? If the answer is yes, visit us at brilliantlabs.ca to learn how. And remember, stay brilliant, and we'll see you next time.